Okay, good morning, afternoon, or evening, everybody. Welcome to the Making Waves PO.DAAC's Journey from Servers to the Cloud Environment Earth Data webinar. This is your host, Jennifer Brennan. It is 2 p.m. Eastern Daylight Saving Time, so we're going to go ahead here and get started. First, what I'd like to do is go over a few webinar logistics. To ensure the best audio experience, you've all been placed in silent mode. But if you have any issues or questions, please enter those into the Q&A pod, and you'll find that located on the right-hand side of your screen. This works like a chat. Today's webinar is being recorded. The recording will be posted both to our online Adobe Connect webinar catalog as well as to our NASA Earth Data YouTube channel within a few days of completion. Actually, I hope to have that completed sometime tomorrow, but if not, certainly by Friday. Once completed, I will send an email to all registrants that will include the recording link. As far as timing is concerned, today's webinar will be 1 hour long with 45 minutes allocated to the presentation and demonstrations and an additional 15 minutes for the question and answer period. We will have 2 speakers today. Our first speaker is Mike Gangle, who is the PO.DAAC Cloud Delivery Lead and System Engineer at NASA's Physical Oceanography Distributed Active Archive Center, or PO.DAAC. Our second speaker is Dr. Catalina Oida. She is the Science and Cloud Services User Engagement Lead, excuse me, and also an Applied Science Systems Engineer, also at PO.DAAC. What we will do, I'm going to pull up to speak to the agenda at a very high level here. What we'll do is we'll start off today's webinar with an introduction to PO.DAAC and the cloud efforts. And then from there, we will go into some depth discussing the new cloud paradigm and the impacts to users. So we'll wrap up today with a few data discovery, data access demonstrations, and information about what is coming next. And then from there, we'll move to a final optional set of polling questions. Usually we give these about 3 to 4 minutes or so, and then we'll move directly to the Q&A period. Depending upon the volume of questions we receive, we may extend the Q&A an additional 15 minutes from end time for those of you who may wish to stay on the line. But we will have a hard cutoff at 3:15 p.m. With that, it is my pleasure to introduce today's first speaker, Mike Gangle. Mike?
Thank you, Jennifer. You should all be seeing my screen now. This is our presentation. Again, my name is Mike Gangle. I'm the PO.DAAC Cloud Delivery Lead, and Catalina Oida is our User Science Services Lead. I'd like to thank Jessica Hausman and Suresh Vanan. They're 2 integral parts of PO.DAAC who've helped us put this presentation together, and then the rest of the PO.DAAC team that's done a lot of the groundwork behind us. In terms of what we'll be covering today, we're going to go over that PO.DAAC overview. We're going to go into why the cloud, why is PO.DAAC moving to the cloud, and what does this mean for the users, their workflows, the opportunities, and the cost models and things that you can expect from that perspective. We're then going to go into tools and services and some examples and demos, whether it's some screen shares or some Jupyter notebooks, that type of thing. And then we'll go on to the Pathfinder data sets and then the resources that will help you on your journey into the cloud. By the end of this presentation, we should be answering the following questions. One is, why is PO.DAAC moving to the cloud? How will this affect the existing model of download and analyzing in the near term and the long term? So that's something that many of you are used to doing, and how will that change or not change? What is PO.DAAC exploring for the future of cloud and cloud computing? What data will be available in the cloud, and when will that data be available? And then ultimately, where can you help get started on your journey using the cloud services, or ultimately doing your analysis in the cloud? So we are the Physical Oceanography Distributed Active Archive Center, or PO.DAAC. We are an element of the NASA Earth Observing System Data and Information System, or EOSDIS. Our focus is on archiving and distributing physical oceanography data, including observations such as sea surface salinity, sea surface temperature, ocean currents and winds, and many others. We offer a range of tools to support our end users in discovering, visualizing, and accessing data. We have about 600 public data sets right now and about 500 terabytes worth of data. That's about 15 million distinct data files and a user community of about 50,000 distinct users served. One of the missions that we have coming up in the fall of 2021 is the SWOT, the Surface, Water, and Ocean Topography mission, and that's a big driver for why we are moving to the cloud. So as you can see in this graph on this slide, there's we call it the hockey stick. Around 2021 and 2022, we go from a Earth data archive size that's around 15 petabytes, 20 petabytes, and it's going to shoot up to over 200 petabytes by 2025. So how do we deal with that data? The cloud is the way in which the Earth data systems are going to manage that large data volume. How we're going to address the performance and scalability of services that our users have come to rely on. It also allows us the chance to co-locate synergistic data sets next to one another, so you can do interesting things across multiple variables and multiple data sets and multiple collections. It also allows the user to possibly bring their analysis to the data. So from that point of view, we really want to understand what the cloud allows us to do, how it's going to help us do our job. And to speak a little bit more about those impacts to the user community and those future paradigm changes, I'm going to hand it over to Catalina to discuss that.
Thanks, Mike. Hopefully everyone can hear me. I think I'll get a ping if you can't. So what does this new paradigm look like? In this diagram that you see on the right, is trying to show schematically, trying to convey the architecture of this new system, if you will. So in the new paradigm, you have the data production, and then, of course, the data storage, the data archive, as well as DAAC-provided tools and services that are built on top of the data, all co-located in the cloud. In this case, we have the Amazon cloud as a side note. So what does this mean to you as the user of the data? The answer is sort of twofold. So by having both the data storage and the services in the cloud, we as a DAAC can continue to provide the same levels of service while handling that large volume of data that Mike just mentioned, by leveraging things like the scalability capability of the cloud. And then on the other hand, with these services being co-located, by using those services, we can hopefully help minimize the amount of data that you as a user has to work with. So make the data more analysis ready on behalf of the user. So whether that's you're doing the download and analyze sort of workflow, or if you're looking to do things in the cloud. And so in the next slide, sort of which category do you fall into or prefer to fall into, you might ask. So one way to think about it is to think about your workflow. What data do you need? What do you do with the data? So once you've sort of discovered and selected that type of data for your particular use case, perhaps using some of these tools and services as well, how much data are you left with and what do you use it for, right? So think about the download time, how much storage you have or you might need for that data, how much analysis or processing you do. Are you a modeler? Do you use an HPC environment? So if that data volume is sort of acceptable and you can handle it, downloading the data and working with it on your local cluster or local server is more than reasonable, and it's an efficient way to go. So as a reminder, I do want to point out that the download of the data off the cloud is and will continue to be free. So you may recall that NASA policies to make data freely available and free to download. So not all users will start working in the cloud or move their entire workflow to the cloud, but you can still take advantage of these cloud-based services that DAAC provides that aim to ease that access to the data. And in the next slide, if that data volume, on the other hand, is still it's becoming too large to sort of handle, you're getting into the several gigabytes, perhaps maybe even terabytes, you might want to consider doing some or all of your science and application workflow in the cloud. So now you're bringing and you're doing your analysis next to the data, as opposed to bringing that data off the cloud to your analysis. So the data, the DAAC services you may use to down select or pre-process your data and your own analysis can then all be co-located in the cloud. So you don't have to wait for the data to download. You probably don't need to buy additional disk space. And you can leverage the scalability that the cloud offers to perform analysis more efficiently. And again, exactly what this looks like would depend on your particular use case or workflow. In terms of the cost, again, accessing that NASA data and DAAC data, even when it's stored in the cloud, is still free to access. But just like you have to consider cost of a local server or perhaps the cost of using an HPC environment, you still need to think about the cost of processing and analyzing, perhaps even storing data in the cloud, whether that's for a short term or long term. So towards the end of the presentation, we'll point to some resources that can help you detangle and think about what the cost model looks like in the cloud paradigm. So think of this evolution to the cloud as an opportunity to explore new ways of using Earth data observations and new ways to perform science research and applications with big data. So how do you go from zero to the cloud, we as a DAAC and you as a user, you might be asking. So this timeline on the next slide is showing the transition and that evolution. In the first phase, we're migrating existing functionality to maintain that same level of service that we have been providing. So I mentioned before that we'll have both the data storage, the data archive, and those services co-located in the cloud. So to achieve that, we are migrating that existing functionality into the cloud so that you as a user can continue to use those services that you're used to using. So you can still do spatial searching, search by variables, perform transformations like reprojection or formatting the data. But the DAAC is handling all of that on the back end in the cloud, which makes us more efficient in handling big data volumes on behalf of the user. So along with that, we're also adding new capabilities because we as a DAAC, as PO.DAAC, the Physical Oceanography Data Center, will actually be hosting the SWOT mission data, which some of you might be aware will be providing measurements for both the oceanography and hydrology and coastal communities. And so the hydrology community is sort of new for PO.DAAC, and we want to make sure that the right tools and functionalities are in place to help with sort of more hydrology-focused workflows as well, on top of the sort of ocean community workflows that have been in place. So, and I'll get back to some of these capabilities in a few slides. And then looking more towards the future, so that blue box on the right, we as a DAAC are working on functionalities that support that sort of next generation access pattern, things like analysis in the cloud, integration of other data sets, enabling cloud optimized data formats to really help leverage what the cloud has to offer. So that was sort of an overview of why and how we're moving to the cloud and a high-level discussion of what this paradigm looks like. So let's go back and explore in a little bit more detail some of the DAAC capabilities and by providing some sort of use cases or steps that you would take as a user. So on this next slide, let's look at searching capabilities first. That's probably one of the first steps you sort of take in order to discover the right data for your needs. So what does searching in this new paradigm look like? In some sense, searching will look exactly the same, but also you will also have some enhanced functionality, both on the front end and the back end, and you'll see what I mean in a moment. So you'll still be able to search using a user interface like the Earth Data Search portal, and if you're not familiar with Earth Data Search, it's a portal that brings together data from all the NASA DAACs. So you can search, you can filter to narrow down that subset of data that is most useful to you. And this becomes especially relevant when you're working with a very large data set, like the upcoming SWOT or NISAR mission. So in this demo, we'll show that along with a new added feature that might be of interest to the hydrology or coastal communities, and that's the ability to search by hydrologic unit code. So Mike, if you want to hit play on that, on the video, So here we are on the Earth Data Search portal, and you can see the URL up at the top. On the left-hand side, you have several filtering options, which can be quite useful given that there are nearly 6,000 dataset collections. So let's say that you are a researcher that's interested in coastal data. You can start by typing a keyword in that search box, something like coastal. And this will help narrow down. Now we have 224 collections instead of those 6,000 that we started with. And you can scroll down to see what those collections are and sort of explore. But that might be still too many data sets to look at. So since you're interested in coastal data, in this case, we can go to the left-hand side and select the PO.DAAC data center to help us narrow things down further. So now we only have 12 matching collections. So again, you can scroll through and see what is available. This ALJSON2 coastal altimetry might be of interest. You can click on it, and that will show you all the granules that's in that collection. But remember, we didn't do any spatial or temporal filtering yet, so it's showing all of the granules. So you can click on View Details, and that takes you to related links. If you click on the PO.DAAC link, then you will go, so you can go ahead and access that data from PO.DAAC using something like the PO.DAAC drive. But let's go back to Earth Data Search Portal, and let's narrow down the data even further by doing a spatial search. So under Advanced Search in the top bar, you have the option now to search by HUC, or hydrologic unit code. And you can do that by typing in the name of the HUC or the ID number. And so I already know I'm interested in the Chesapeake Bay, and I know the ID number, so I'm going to copy and paste it into there and click Apply. And the top panel shows the map, which visually confirms your spatial search criteria. So we can see that we're over the Chesapeake Bay. And now we have 11 collections to work with. And if you scroll down, you can find that data set, the ALJSON2 that we had found before. And from there, you can continue on with your workflow. But that gives you a sense of how you can still continue to do searching through using a user interface. If you prefer a more programmatic way of searching, on the next slide, here you can see, so if you prefer a more programmatic way of searching, you can use the API that we've built behind the HUC search that you just saw to query data spatially for your region of interest. So we created a Jupyter notebook. You see a screenshot of it on the right-hand side. If you're not familiar with Jupyter notebooks, they're really cool and great to use. They're sort of shareable bits of code. This particular Jupyter notebook that we created walks you through the API and the options it offers when you're trying to search by USGS HUC. So you can define things like your region of interest, both by doing a partial or an exact query of that HUC. You can preview the HUC and then use those coordinates to then further query data in CMR, which is the Earth Data Common Metadata Repository. So if you're a user of HUC, hydrologic unit code, this is another resource you can use and adapt to your needs. And next, Mike will demo additional search capabilities by using your own shapefile as opposed to these predefined HUCs.
Thank you. So yeah, Catalina did a great job of talking about the unit codes that a lot of hydrologists use. One of the issues with those unit codes is that they're primarily for America or North America only. And so you might be a user who's interested in a different region altogether. Maybe it's sub-Saharan Africa, or maybe it's a river or a basin in Southeast Asia. You might not have the same kind of ability to have a nice predefined code that says this is exactly the region or the watershed I'm interested in. And so some of the things that have been worked on the Earth data and the CMR side, again, are shapefile searchings or other kind of GIS-based searching techniques. So what we're going to show here is another demo that goes through that Earth data search again using shapefiles. We're going to use Earth data search. In the next demo, we'll use Jupyter Notebooks to kind of show you how to do this programmatically. But essentially what we want to do here is kind of find out how to use those common GIS files and data sets to explore and find Earth science data of interest. This will be really useful for that GIS community that we've referred to. We're noticing a lot more application users coming into PO.DAAC, and those are people who are very comfortable using things like ArcGIS and QGIS. And again, the relevancy here to the cloud is not so much that you're doing something in the cloud, but with missions like SWOT and Sentinel-6 and a lot of the other big missions coming up, you're looking at tens of thousands of files being ingested per day, and finding that data is really key to limiting your problem space and just finding the data that you're interested in. So I'm going to go ahead and start this demo. We're going to start in QGIS, which is a popular free GIS software application. GIS users often use file formats like Esri shapefiles to define their region of interest. Here we're going to define a region that looks a lot like the Gulf of Mexico, and I've saved this shape in a shapefile and will now show you how you can actually use that in the Earth Data Search UI. We've already shown that UI, so we're not going to go too in-depth on what that is, but I did want to point out that here we're going to use a level 2 collection or SWOT-based data collection that looks at sea surface temperature, and we're using this PO.Cumulus provider, which is a kind of our test collection to kind of do things with. If I go into the map here, you can see I can highlight over these granules. You can see that they're actually in SWOT, so it's not some large bounding box. They have very specific regions that they're covering, or footprints as we call them, and they light up to show you kind of which one is selected. What we can do, because these go all over the globe, is we can kind of go and click on this file option, and then we can go through and see which various formats are accepted for doing a spatial search. So we can see the Esri shapefile, keyhole markup language, or KML. They also support things like GeoJSON and GeoRSS. And all you have to do is basically grab that file and drop it into your window. And now you can notice that that polygon once again shows up very similar to how it did in QGIS. And that those swaths are now down selected to only show the ones that actually intersect with our region of interest. So we've already kind of down selected onto what we're looking at. And again, this is really important when you look at those collections that are going to have thousands, if not hundreds of thousands of files coming in today during the bulk of their reprocessing campaign. Yeah, so that's just kind of the idea behind using these shape files in a search. Again, shapefile is something that's very comfortable of use to GIS community. So if you're familiar with ArcGIS, QGIS, maybe even Google Earth, Esri shapefile is kind of one of those standard formats that you use. Now, maybe you already know your collections and things like this, and you're more interested in doing this programmatically. You don't want to sit in front of a screen. You want to look at or you have code snippets and you have processing pipeline set up, and you just want to find the data and feed that into your existing processes. So what we're going to do now is we're going to show you that same demo, only using all Python to basically do it. So we're going to use some Python in a Jupyter notebook, that same shapefile, and we'll also show you how to do this the command line if you really want to get kind of esoteric with how you want to do these things. You can use curl to do it as well. So this is the same community of interest. It's going to be GIS users, but more on the power end of things, so very API-driven, very comfortable getting into the code and doing things like that. So let's go ahead and start this demo as well. And so the Common Metadata Repository, or CMR, is the catalog that backs many of our Earth data tools. So Catalina mentioned that when she was doing the HUC feature lookup. We've previously shown that Earth Data Search UI, which is a very powerful and visual way of searching for data, many of the same features that are enabled there are enabled by the CMR itself. And so some users are more comfortable with that API or command line access and prefer to get their search results and their data discovery done more programmatically. So in this notebook, we're going to run through the basics of uploading an Esri shapefile to the CMR and retrieving those results. For this notebook, we're going to be using a collection identifier to search for granules or data files that are specific to a collection. We're not going to go into a lot of detail on how to do that, but we do have other Python notebooks that show us how to do that. And so those tutorials can be found on our PO.DAAC GitHub with some of the links that will come later on. Before we begin, this notebook is going to be accessing our test CMR server, so the functionality is not quite operational yet, but will be very soon. And we're going to begin with the Python 3 version of this tutorial. In only about 10 lines of code, we can show you how to find those granules that interact with that uploaded shapefile boundary. So the first thing we have to do is define a few libraries. The most important one here is the request library that simplifies making HTTP or URL requests. That's basically how the internet talks to each other. Then we go on to define some URLs or some variables, the first being the CMR URL. Then we need to define the shapefile that we want to use. And one Python thing is we want to open that up in binary mode so we don't have any errors. Then we have to define the file that we're actually going to send to the CMR. So that's where I'm getting to this shapefile.zip file, which is available on our PO.DAAC GitHub. And also this shapefile plus zip is the MIME type, or how do we tell the server this is what you're looking for. Lastly, we're going to define that collection ID that we're interested in. Again, we got that collection ID from some of the other tutorials that we're working on. And then all we have to do is go ahead and run this as a post request. So we upload that file, and you can see the results kind of come back pretty quickly. The results will turn a lot of information, such as the download URL, start and stop date ranges if they're available, the polygon or the bounding box information, and so on. We could continue to parse this. We could download the files, access these files via PO.DAAC, or even add more search criteria to kind of down select what we're doing. But that's kind of what we really wanted to show on this portion of it. Now I'm going to kind of shift a little bit and show the curl command line. Curl is a great utility because it comes on almost every Unix or Linux installation, so it's just kind of quote-unquote there. We're going to run a very similar command here. So we've got our shapefile, we've got our collection ID, we're doing a post. We are going to do this nice pretty equals true, which is just kind of a nice little way of formatting the results for you. And when we run this one, we're actually going to return the XML results. So we have a lot of ability in CMR to return different formats that you might be comfortable with. Maybe it's JSON or maybe it's XML. So you have a lot of options there. When we run this one, you can see we get back a certain number of results. This one has 1,912 results that intersect with our area of interest. So again, we just kind of wanted to show that there's a lot of different ways to interact with the data that PO.DAAC has, that other Earth data search users might be interested in across the DAAC. And these are just things that really make finding your data in a way that's comfortable for you a lot easier to do. So let's continue moving on. So we've gotten to the search and download portion, and a lot of that hasn't changed at all since you've started looking at what does PO.DAAC look like in the cloud. Now we are going to head into some of the places where maybe things do start to change a little bit for a user scenario, or maybe they don't. So what we're going to end up doing is going through a couple of demos or presentations on different ways of accessing that data. One of the first and foremost ways that people want to get at the data is they just want to get at that information that's actually relevant to them. So once they've searched, they found a data set that's interesting, maybe they're only interested in a certain region. So subsetting is the way in which we essentially do that across all the NASA data centers, and subsetting is how you can get that data that's really just key to what you're trying to do with the data scientifically. So here we're going to go through a Jupyter notebook. Again, this is going to be really interesting to those power users who are very API driven, and also regional users, so maybe not a modeler who needs all the data, but a more regional-based user who just wants to get, the Gulf of Mexico or a certain river basin. So let's go ahead and get started with this particular demo. So one of the more traditional data access functions that users want to utilize is subsetting. Many different subsetters exist, and a lot of that depends on the type of data. Here we're going to showcase the PO.DAAC Level 2 subsetter, which is designed to subset SWOT-based data. So it's not as simple as this measurement lines up with this latitude-longitude point. You have to do a little bit more there. Because requesting a subset is a form of data access, users must log into Earth Data Login with their usernames and passwords. If you don't have a login, that's okay. It takes about 3 minutes to set one up. Earth Data Login helps us understand who is using what types of data. You know, are you a researcher? Are you an application user, such as a government or a resource manager? And then finally, what type of data are you using? Are you looking at level 2 ocean data? Are you looking at level 3 gridded products? Earth Data Login also allows us to contact you if there's an update to a data set. So the first step in this notebook is to actually set up that authentication. We provide a lot of boilerplate code for doing this, so you don't have to figure it out on your own. Let's go ahead and just kind of run through this. I'm going to enter my username and password, and that just kind of sets us up to actually accessing a lot of this data. So once we do that, we're going to start building the route for our API call. We're going to use an API called Harmony right now. One aspect of Harmony is that it provides a unified interface into different Earth data holdings, so not just PO.DAAC, but maybe the LP.DAAC or NSIDC. Harmony is a bit outside the scope of our demo right now, so I'm going to just kind of generalize it as just an API that we can call, but it is in test right now. It's one of those things that we want to push out soon. So much like the previous demos, we're going to use an existing collection ID that we found through our CMR searches, and we're also going to define a specific granule that we want to subset on. Normally, a user wants to subset on a lot of granules or just a date and time. That's functionality that's coming up in the near future, but this is just a use case looking at a singular aspect of this. So let's go ahead and get to the meat of this demo. Here we're going to kind of define, this is the URL and the granule object that we want to subset. So here you can see me hovering over the granule configuration, so that's specifying this is the granule I want. And we also have a subset, so this is a bounding box where we have our west and east longitudes, south and north latitudes. So this is a pretty large bounding box, but it's just to kind of demonstrate what's going on. When we go ahead and run this code snippet, there's a lot that's actually going on. First and foremost, that it's doing all that Earth Data Login interaction for you, so it's authorizing you to actually access this data. And then it's going to send the request to the backend system to say, let's go ahead and subset that file and return it back to the user. We're going to end up creating a file called tempnc, and we're going to get some information about that, such as the size of it. So it's about 6.3 megabytes here. And you can see by running this, we've downloaded that file. You could then go ahead and use this in, Panoply to look at it and investigate it, or you could do some X-array NetCDF kind of instructions on your computer to actually interact with that file. One of the great things about using Harmony, though, is we can also run this subsetter on a data file using the OGC API. So OGC is the Open Geospatial Consortium, and they set the standard kind of for location information and services on the web. There's a lot of clients that are integrated with these types of calls. So QGIS, which we showed earlier, you can simply run this query, which uses the OGC RESTful syntax, and we'll get that same result. So you can see I just ran it, and we get that same content size, that same download. Those two files are exactly identical. It's the same code on the back end, doing all this type of stuff. And what we're trying to show you here is that maybe you're very comfortable using APIs, or maybe you have a tool into using APIs that exist, but we're trying to support both of those user communities and both of those use cases without making the user learn a lot about cloud-native technology. Now, if we are interested in something that's more cloud and what to do with more cloud-optimized data, Catalina is going to show us a pretty cool presentation that we've recently seen and that we're a part of that really gets to the heart of what you can do in the cloud moving forward.
Yeah, thanks, Mike. So the next slide, and there might be a little bit of a lag. Here we go. Awesome. So like Mike said, if you wanted to explore what it's like to work with data directly in the cloud, you can give it a go with the Muir SSD sea surface temperature data set. So the Muir sea surface temperature collection is now in AWS or Amazon S3 storage space as part of AWS or Amazon's registry of open data. It is also, this particular data set is also available in this case in a cloud optimized format. Here it's in what's called STAR. And if you go to that link at the top of the page, that's where the announcement of the data set being released is posted. And on that website, you will find several resources anything from how to access the data to exploring it using one of PO.DAAC's tools like SWOT, Data of the Ocean, or you can do some analysis in Python using several Jupyter notebooks that we've sort of been talking about previously. And so I want to mention, so Miro might not be useful for everyone, like you might be a hydrologist, not an oceanographer, but to begin with, this is one of the data sets that's kind of the trailblazing for being in the cloud, being in cloud optimized format. So you can still kind of poke around and give these Jupyter notebooks a go and see how they work, just to get a sense for what it's like to work with the data and having your analysis close to the data in the cloud. And so on the left-hand side, I'm showing a screenshot of one of the Jupyter notebooks that are available with this data set release. And so you can run this notebook the way Mike was running those notebooks, probably locally on his computer. In this case, you can run these notebooks directly in the cloud. So again, you're bringing that analysis to the data in the cloud. And this particular notebook is set up to let you explore the data, so see what the metadata looks like, what the data is structured, how it's structured, and then do relatively simple, if you will, calculations, things like SST anomaly globally, and then make other more complicated plots and analysis. So if you run through this, you will, one main takeaway that's I think really, really cool is that you can basically compute a global SST climatology anomaly from a very high resolution, 1 kilometer daily data that's available from 2002 to present in just seconds, which is kind of mind-blowing and super cool. So that's what I'm highlighting on the right-hand side with the yellow sort of circle there. So when I run this notebook in the cloud, thank you to Pangeo, shout out for setting this up and allowing users to sort of test it out and see how it goes. When I run it, you can see that it only took a few seconds for it to compute this global high-resolution SST climatology anomaly. So what used to take hours and hours to process and analyze can now take seconds to a few minutes, perhaps, depending on what you're doing. And so then once you've done this sort of relatively simple SST anomaly, you can then go quickly. You can then move forward and do more, detailed, complex analysis. So you don't have to spend so much time on quote-unquote simpler things, but can go ahead and do other analysis. So all of this is being done by sort of leveraging that, by scaling the processing in the cloud, in AWS in this case, and leveraging new powerful community-based, community-developed libraries and tools like Pangeo, and using cloud-optimized data formats. And that's actually a good lead into the next slide, talking about cloud-optimized data formats. So I'll pass it back to Mike to go over that.
Yeah, thank you. So we kind of showed you the more traditional API-based access into getting your subset and us doing some of that work for you. And then Catalina showed an example of data that's natively in these cloud formats and what that entails and some of the things that are open up to users. And we're really walking that line on providing both to our users. But we did want to talk about a little bit more of how we're approaching that problem space and what our thoughts are on it. And so from the more to come, it's really more focused on analysis and making that data analysis ready for our end user. So what we start with is going to be, archive files. So maybe that's a netcdf file or even ASCII or CSV or HDF or shape files or maybe a classical TIFF image. Those are the archive files that a lot of the DAACs are used to. And when you move into the cloud, you have some ability to kind of play around with that. One of the things we really want to look at are reformatting to those cloud-optimized data formats. So whether it's DAR or cloud-optimized GeoTIFF, those are things that we are really interested in making available to the user. And we just have to figure out, are we going to do this on demand for the user? So you request the area that you're interested in, and then we let you, do the chunking and this is how we want to set up those actual DAR or cloud GeoTIFF files, or is this something we do at ingest time? So we make all of our formats available this way. Those are some of the decisions that we're still trying to wrestle with, but we know we want to go down this path of making them optimized ready and cloud ready. The other thing we want to do is make it simpler just to use that data in general. So instead of giving a user, all the bells and whistles and saying, okay, now figure out how to make this data work with your other data, we want to look at ways of making it easier to reformat to other popular products. So maybe that's a Landsat, Sentinel, or a MODIS product. We want to make sure that it's trivial to get data to work with those, but at the same time still allow all those knobs and levers and gears, such as the grid interpolation strategies and what actual resolutions do you want to find. So finding that balance between making it easy to use data and then making the data work exactly for your user situation. We want to kind of go around hitting both of those points. But in order to do any of this kind of stuff, it's really important to actually have data to be working with. And so, we've talked about Sentinel, we've talked about NISAR, we've talked about SWOT. All those are more future-oriented data sets. They're coming at soonest in November of 2020 this year. So PO.DAAC's working on bringing some other popular data sets as pathfinders into the cloud to get users accustomed to working with these new services and even working in the cloud. So we're looking at a lot of like sea surface height and gridded water heights to get used to SWOT and the Sentinel products. But we're also looking at some gridded sea surface salinity, so the SMAP product, GRACE, follow-on mission, and then the measures gridded SSHA. That's all to get us ready and to test out our tools and to get the user community into the cloud and working with this data for something like JSON CS, which is, again, launching in November. JSON is a continuity of service mission on the Sentinel-6 spacecraft. It's an international partnership between the U.S. and the European Commission Copernicus initiative. So the goal of these satellites is to essentially carry on that record of sea level change for for the foreseeable future, 10-ish years or so. But there's other DACs that are bringing data sets in. So PO.DAAC is going to bring in a product called the Harmonized Landsat and Sentinel data product. We've seen a lot of our users want to use the PO.DAAC data or other GIS type users really interested in Landsat products, really interested in those Sentinel products. So this is another product that's getting into the cloud that will be open to any Earth data user to go ahead and play around with, get used to working in the cloud. And then there's also all the other DACs are currently bringing on board, or many of the other DACs are bringing on board other data products. So NSIDC, GHRC, the LP.DAAC, ASF. These are all DACs that are currently moving into the cloud. They're trying to do the same things as we are, and we're trying to make it a common approach so that a user coming to get PO.DAAC data can do the same things to get ASF data or satellite data or STAR data, something like that. So now that we know a little bit more about the services and that data that's coming into the cloud, Kathleen is going to share with you some resources on getting help and getting spun up into your user journey into the cloud itself.
Yeah, so one great way to get spun up, like Mike said, is to check out the cloud primer that several DACs or data centers have put together. I should say it's not quite yet available, but we do expect to release it later this spring. But the idea behind this cloud primer is is for those, if you're new to the cloud, specifically, especially if you're new to AWS, the Amazon cloud, this is, your AWS 101 primer. So it's a set of tutorials, roughly a dozen or so. And in the center there, I'm listing sort of the titles for most of the tutorials that are in the set, in the cloud primer. It includes things like, why we're more philosophical discussions, if you will, of why we're moving to the cloud, what the cost structure looks like, and understanding the cost if you work in the cloud, things that we've sort of touched up on earlier in this webinar. But then also has more sort of practical tutorials of how to set up an instance, which is sort of another way to say a virtual machine in the cloud, how to set up storage in the cloud, ways to move files from your local laptop or server to your cloud instance, or moving those files back down to your laptop from the cloud, how to access public data from the AWS S3 bucket. So S3 is just the storage space in Amazon Cloud. So accessing existing data sets in the Registry of Open Data on Amazon. So things of that nature. So again, if you are completely new or relatively new to the cloud, this is a good way to sort of get your feet wet, understand what it's like to set up that environment and work with it, and link back to those data sets that Mike was pointing to and start sort of playing around with some of that. So again, we expect to make this publicly available later this spring. So check back on the PO.DAAC website to see when that gets released. And then finally, on this last slide, we've compiled some of the links and resources that we've talked about today. And Jennifer and I will also be sharing several more specific links to the specific tutorials and demos you saw. But if you go to the PO.DAAC Cloud Tutorials link, which is the second one here, that has a lot of the Jupyter notebooks that Mike has shown today. PO.DAAC GitHub has many, many more other sort of tools and services by PO.DAAC and as this that you can check out. We will continue to add notebooks and other resources both here and on the PO.DAAC website. So do check them out frequently. I've already mentioned the Cloud Primer. We hope to hold an in-person, we're planning for it, and we hope we can still hold an in-person workshop at the SWOT science team meeting this summer, sort of help the science team learn about these tools and how they can leverage them to access future SWOT data. We're also planning in the planning phases for a cloud hackathon. And again, this will hopefully be in the fall, in the later months of 2020. And it's another opportunity for users to come and do hands-on sort of work and practice with a lot of these and sort of start to integrate these tools and access pathways into your workflow in sort of a hands-on environment. So we'll be posting updates on that as well on the PO.DAAC website. So again, check back there. And finally, just a quick note that we have updated and we have a new PO.DAAC SWOT website. So for those people interested in the SWOT mission coming online soon, well, in the next couple of years, there's a lot of mission and data product information available on that website, things like spatial coverage of SWOT for both the hydrology data products as well as the oceanography data products, and suggested complementary data sets to SWOT. And with that, I think I just want to say thank you very much for joining us today. Again, I'm listing here the PO.DAAC website and the Twitter they can reach us at, as well as the email address. If you have questions, we want to hear from you. We hope that you found this webinar informational and it started to sort of answer some of your questions. And yes, get in touch with us. We do welcome feedback and questions. We want to know what you're thinking and what your concerns are. And with that, I will pass it back to Jennifer.
Okay, thank you, Catalina. At this point, we are going to transition to a final optional set of polling questions. We'll give these about 3 minutes or so, and then from there we'll move directly to the Q&A. We do have quite a few questions within the Q&A, and so I just wanted to make a quick note that if we do not get to the questions either during the regular Q&A period or the extended time frame, which will end at 3:15 Eastern Time, then I will send the log to our speakers and they will be able to follow up offline with all of you. Okay, if for some reason the question, we just don't get to it. All right, so with that, we'll give this a few more minutes and then we'll transition directly to the Q&A. Thanks, everybody. Okay, we're going to give the questions just one more minute, and then from there we'll move to the question and answer period. Okay, everybody, at this point, just really quickly, and I will come back to this. This is the web links pod, which includes links to the data products as well as links that were mentioned during the framework of the presentation. Once we are done with today's Q&A session, I will jump back to this location if you're interested in checking out any of those links. But it is a persistent feature, so if you listen later on, you'll still be able to interact with that particular pod along with the file sharing pod. And so for those of you who asked about the presentation files, in the lower right-hand corner, you'll see the demo video files as well as the presentation without the videos. To download any of those files, you're going to click on it. It'll be highlighted, and you should be prompted with an option to download the file. With that, let's go ahead and start with our first question. We have quite a few. The first question is, will all of the DAAC data be on open data on AWS?
That's a good question. Right now, the answer is no. That has to be an agreement between a data provider and the and AWS. So there has to be a certain level of support there and some timelines for if we're getting a bunch of reprocessing, reformatting. How does that go there? So while some data will be available via the open data portion, all of the data that we put in the cloud will be available by the DAAC interface, some of which will make its way to that open data depending on its usability.
Yeah, just to quickly add to that, so there's one big AWS cloud S3 bucket, and all of the data gets stored there. So, NASA has an agreement with AWS where we have all the DAACs eventually put the data sets into the cloud. Then there's also what Amazon is offering through a separate set of agreements that Mike just mentioned, which the users can access to that, what's called the Amazon Registry of Open Data. So there's sort of two different ways to access data, and there might be sort of separate data sets available through those two channels, but like Mike said, ultimately, all the DAAC NASA data center data will be in the Amazon cloud. Hopefully that makes a little more sense.
Okay, thank you, Catalina, and thank you, Mike. We did have a question earlier on, and I believe this is likely a question from one of our DAACs holding atmospheric data products. So how can we measure metallic contamination in air using satellite images? So unless you have something to add, I will follow up with this user offline with some additional resources and DAAC POCs.
Yeah, I think that sounds good. I'm not sure that we have a lot of details on that particular scenario.
Exactly. So I will follow up with that user offline. All right, let's move along here. Does the API for Earth Data Search allow for time selection?
Yeah, so we only showed one of the newer selection or search criteria. Yeah, you can do a lot of different types of search for time. So if you want to do, this is my time range, I think you can even do seasonal time. So if you want to look at every summer, that type of thing, there's a bevy of time range options that you can look at on the Earth Data Search and the CMR itself.
Okay, thank you. And so your next question is, and this was a question that was posed during the demos. Can one do what is done with Python using other tools, for example, IDL?
So I don't have a lot of IDL experience. If you can make a call to a server with IDL, then there shouldn't be any reason why you can't do it with IDL. We use Python because there's a lot of scientific libraries that are installed. There's no licensing, and a lot of the user community uses it. But we do know that there's many other software packages that should be able to use these APIs, and that's one of the beautiful things about using these APIs is that if there's a user community to support it, then they have a way of accessing those APIs from a whole host of various tools, whether it's Java, Python, IDL, MATLAB, et cetera.
Okay, thank you, Mike. The next question is, ocean color data, operational daily data for level 2 Modus Virs, is that available from this interface? So that one can avoid subscription service currently being used for that purpose. Now, I did provide a direct link to the data landing page at OB.DAAC, but I wanted to make sure we're not leaving something out, and PO.DAAC can allow you to address this.
Yeah, so I'm not, I do believe that is the OB.DAAC product, so it's not available by this interface currently, and I can't speak to future plans to integrate that. But one of the, I did mention this Harmony interface at one point during the demo. One of the hopes is that can work for both data in the cloud and data on-prem. So the idea is that you don't care which DAC has that data necessarily. It's the same access mechanism into it, whether that's OB.DAAC, PO.DAAC, or on-prem or in the cloud. Our hope is to make that just an ubiquitous kind of API to getting at data. So my hopeful answer is that eventually it will be.
Okay, thank you, Mike. And then another question. This all seems very Python specific, and this was, during the Python demos that you were conducting. Can you address some more general solutions?
So it depends on which demo we were looking at, and again, like I mentioned, the other question, Python is one of the more heavily used programming languages, but there's nothing to stop a user from using any other programming language to do these things. We tried to show doing these things by a GUI, so the Earth Data Search client to do these things, and I'm sure we will build tool sets on top of these APIs for users. So if you're a PO.DAAC user, maybe you know about Soto, or maybe you know about high tide tools. There's no reason that those types of tools can't be integrated with these APIs. And so while we're showing Python, it can be anything. It can be Scala or Go if you're even into some of these more newer languages. It's just an example of doing this and showing a way of doing it that we find helpful for a lot of our users. But if there's a user community that wants to see different notebooks, we can certainly start putting those out there. Or if you want to do it and contribute it back to us, we can put it out there for other people to use and learn from as well.
Okay, wonderful. Thank you, Mike. The next question is, I'm wondering if it will be possible, if inter-cloud computing will be possible, cloud app accessing JSON strings.
So I might need a bit more follow-up on that, what they mean by the JSON strings part. From a cross-cloud processing, which I think is what the question was.
Yeah, inter-cloud processing, yeah.
Yeah, so there's nothing to prevent that. You do go across, the normal internet when you do that, so there might be slowdowns and whatnot. And so you'll probably see your fastest speeds if you're next to the data, but there's nothing that would prevent you from doing that from a technical standpoint or a policy standpoint. If you want to use the data, you can use it from wherever you'd like.
Okay, and one of the questions was, do you need a Pangeo account to access the notebooks on the cloud? And I did mention that the notebooks, many of the notebooks you shared today were available on the PO.DAAC GitHub page. But just want to check to see if there's anything else you'd like to add.
I don't think you need a Pangeo account to run it. So when I went to run, I went to the Muir SSC announcement, and then I clicked on resources or the Jupyter Notebook link. I forget which one. And then it takes you to the Pangeo sort of GitHub space. And I don't recall ever having to log in. Now, I do want to say that, so the way they Pangeo set it up is that they set up what's called a binder in the cloud, so you can run this Jupyter Notebook in the cloud. That sort of analysis does incur costs. So Pangeo is sort of incurring that cost through these sort of like test bed or allowing people to sort of play with these tools. But it is an ephemeral space, so it won't be there for the Jupyter Notebook will live on and continue, and you can sort of make a copy and keep it. But running it in the cloud through the Pangeo binder won't always be there just because of that cost. It's just sort of meant as a sandbox, if you will. And I hope I'm doing justice to this. So I don't know if Ryan or Shell are online and they're listening, but yeah, the short answer is no, you don't have to log in, but be aware that being able to run those notebooks through something else, there might be costs associated with that, and so just be aware of it. And eventually you might have to set up your own system to run those notebooks.
Okay, thank you, Catalina. The next question is, what will be the payment mechanism to run the analysis on the cloud?
Another good question. So
go ahead, Kelly.
Yeah, so thank you. So accessing the data and downloading the data will be free even when you're downloading from the cloud. Accessing the data while you're in the cloud is also free. What will cost will be that an extra analysis or processing. So if you're using some of the APIs and tools that PO.DAAC set up that we've shown, that particular pre-processing that the tool is doing, that's on our end, and we incur that cost. If you want to do anything further with the data, any other additional analysis, or if you need a little bit of a storage space in the cloud to do that analysis and store it long or short term, that part is something that the user needs to think about, and that will have to pay for or consider the cost of that. I don't know if you want to add something to that, Mike.
Yeah, so essentially anything that PO.DAAC is doing, you don't have to pay for. But as soon as you receive those bytes, whether it's in the cloud or on premise, you have to support those. Like if you were writing them to a disk, it's your hard drive that you either purchased, or if you're in the cloud and you're storing it on an EC2 instance, you have to pay for your own particular EC2 instance. But to make the request to the subsetting service, you don't have to pay for anything. And I know Byron just pointed this out in the Q&A. While there are costs associated with egress, the users do not have to pay for those costs. Those are all costs, like Catalina said, incurred by the DAACs or EOSDIS. So downloads do not cost anything to the end user. And another person had mentioned the requester pays mechanism. That is not something that the DAACs are using. That is something that we've seen, and it's an ability in Amazon, but that's not something we use. So users won't be charged to get the data.
Okay, thank you, Mike. And just for everybody, I'm asking the questions in the order that they were received in the pod, so I'm working my way down to, there have been quite a few. The next question is, I'm really interested in long-time series regionally subsetting data and downloading it as a ZAR or a zip file, but as it is now, you have to manually download thousands of files. Will this be a feature in the future?
It's like you wrote a user story for us. That is certainly a future. With a lot of the APIs, we want to get away from the idea of granules or specific data files entirely. So if a user wants to say, this is my region of interest and this is the time I'm interested in, and these are the variables that I want. So if it's, sea surface temperature or something, that's the request you make, and we do all that plumbing on the back end to make sure we get all the files, put it into a format of your choosing, whether that's one massive zip file, staging it on an S3 bucket for you, or putting it into XAR or Cloud Optimized GeoTIFF. Those are exactly the features that we plan on supporting for the user community in the very near future, actually.
All right, excellent. Thank you, Mike. The next question is really more the user would like some feedback. Near real-time latency will be the key for many applications. Can you speak to that type of availability? I mean, we do have near real-time data available through LAMP, but if you could speak to if you know anything about near real-time data in the cloud.
So from what I know, the near real-timeness of data is really up to the project that's putting that mission out there. If the DAACs are told to support a near real-time aspect, they do that. So it's not up to the DAAC to decide if something's real-time or not. As for real-time data being available in the cloud, I believe NISAR has a component that's real-time, but I don't want to say that for certain. But there's that can certainly be supported by the cloud architectures. It's not something that we're closing the door on or anything like that. So if there's a need for it, that is something that we will do it. And I completely agree that the application community generally needs a much faster turnaround time on that data.
Yeah, and I think if the concern is from a DAAC standpoint, if the project makes it available near real time, and Mike, correct me if I'm wrong, from a DAAC perspective, from our tests, we've seen that we have the capability to ingest and archive that data quickly, so there isn't a delay from our step in the data processing and making that available.
Okay, thank you, Catalina. Thank you, Mike. And so if you submitted a question into the polling question responses, if you would be so kind as to please re-enter that here. We're basically going through the questions that have been submitted into the Q&A pod at the moment, but that's not to say that your question won't be addressed either here or afterward. Okay, so another question is, can we get notified when the primer is actually available? And I wasn't sure whether you push those types of announcements out to your end user communities, Catalina or Mike, so I defer to both of you.
Sorry, I missed the very beginning of that question. Was it about when?
Yes. So will you notify? Yes. So will you notify users when the primer is available?
Yes, absolutely. So we'll make it available both through the Earth Data Learn section as well as individual DAACs. And as far as PO.DAAC is concerned, I think we will, on our end, sort of, if you're subscribed to something like the forum, you'll get notifications when that will post it there. And if you're on the listserv for PO.DAAC, we will announce it when that becomes available. Yes, definitely.
Okay, thank you, Catalina. We have about 5 minutes left for the Q&A. Is there a centralized Jupyter Hub plan so users can do on-site computing?
That's something that a lot of people have asked for. I think it's really of interest to the DAACs as well, and I don't think there's any reason why we can't do that technically. I think a lot of that comes down to is there like what are the policies behind that? Who pays for that? There's a lot of questions there. So we're investigating that scenario, but I think for the time being, it's easiest to spin up your own Jupyter notebooks to do this processing now, and then. There are a lot of communities out there like Pangeo and the actual Jupyter Hub community that can show you how to spin these things up in the cloud or on a cluster in Kubernetes or something like that. So while we're still investigating that, I don't have a concrete answer for that one moving forward.
Okay, thank you. The next question is for operational users, for example, NOAA, how will the cost model be configured?
So if you're getting data from PO.DAAC, there's no cost. It's just the same as you're doing it today. You'll use these access mechanisms to do it. You can download data from a link or from CMR, just like you might be doing it from Drive on PO.DAAC right now. It's only if you're moving your processing into the cloud that you'll have to pay for that particular processing. Anything that you're getting from PO.DAAC, that won't be charged to you.
Okay, thank you. The next question is, could we access the processing codes for level 2 data? We usually need to know the processing procedure.
So that's usually supplied by the project or whoever's creating those level 2 products. If it is PO.DAAC that's creating those and we have the ability, that's something we would generally try and open source and make available on a GitHub page. You might have to go to the project to get some of the source code. If it's something that we archive as part of the processing, it'll be made available at some point. But without knowing the specific processing code that you're referring to, it's hard to answer specifically. Ultimately, the answer should be it should be available, whether that's during mission or after mission. Has a lot to do with the project agreements and NASA or ESA or whoever's putting together the project itself.
Yeah, and just to quickly add to that, so if the processing is referring to something that the project has done, so corrections to the data, things of that nature, like Mike said, that comes from the project and it is documented and shared with the users. If it's more like pre-processing of the data through these tools we've talked about today, that again, at PO.DAAC, we're capturing that sort of workflow. So if you're subsetting or regridding, that will be sort of capturing the metadata of the file so you know how the data was processed from that meaning of the processing. So hopefully that helps a little bit.
Okay. And so the next question is, this is a user from the United Nations. So from a policymaking point of view, I'm asking, how exactly do you see the future of this PO.DAAC and other data, including that of deep sea mining, especially when we expect an arrival of AI and quantum computing at a major level?
There's a lot to that question. It's almost a futurism question, but I think by making the data available in the cloud environments, we're actually opening it up to not only experts in artificial intelligence, but also leveraging the massive amount of work companies like AWS or even Google are doing in AI to help bring more people into that boat. And so there's a lot of tools like SageMaker and SageMaker Studio that are part of AWS. I'm sure there's other versions of that on Azure and Google App Engine. But these, by putting the data in the cloud, you're essentially making it much easier to do that type of AI and automating insights and do that kind of deep learning on the data products themselves. So I hope that addresses the question.
Okay, thank you, Mike. At this point, we have reached the end of our extended Q&A period, and I know that there are quite a few questions here that have not been addressed yet. So I will be sending the Q&A log to our speakers. They will be able to follow up with you offline. If you have an immediate question, I'll take a look through the polling question responses and go ahead and, I know there was one participant who wanted to have his question answered, so I will forward those along to our speakers, and hopefully they will be able to get back in touch with you quickly. So at this point, we will log off from the audio component and leave the virtual meeting space open. If you have any additional feedback or think of a question, please feel free to enter that into the Q&A pod. I'd like to thank our speakers for joining us today and to thank all of you. We have got some very thoughtful feedback and questions regarding cloud computing, so this was extremely valuable, and I thank all of you for participating. All right, thanks everybody.
Thank you.
Bye-bye. All right.
Thank you.
Bye-bye now.